Hey Math 20-1 students, we're looking at lesson 6.4a, rational equations. So what we're trying to do is we're trying to solve for the variable x. So whenever we have an equation, you're going to have a left side of the equation and a right side of the equation. So you're trying to get that x by itself. So there's a few steps. So first you want to factor the denominator. You want to find the non-permissible values because your answers cannot be non-permissible values. Then you're going to multiply both sides by the lowest common denominator, and then you're going to solve by isolating the variable, and then always check your answers. Okay, so let's start with this first one. First, we're going to get, the strategy I'm going to show you is getting common denominators. So there's lots of strategies out there, but I find this one is using what we've done before. So this is getting the lowest common denominator, which would have been 4x. We need to have the right side and the left side all having this 4x in the denominator. So you're going to have the first fraction is going to be multiplied by x, top and bottom. This guy's going to be multiplied by 4. And don't forget that the right side, that 3, the bottom and the top, is going to have to be multiplied by 4x because it has nothing in the denominator. So don't forget about that. So then we have x squared minus 28 equals 3 times 4x, which is 12x. And the left side is going to be over 4x, and the right side is going to be over 4x. So what we're really doing now is we're multiplying this side by 4x, because what you do to one side, you do to the other, and this side by 4x. And the reason we do get the common denominator is because these guys will cross each other off, and these guys will cross each other off, which will eliminate that denominator. And then we only have to have x squared minus 28 equals 12x to solve for. And how we solve for that is getting it to be a quadratic equation where it's equal to 0. So we're going to have x squared minus 12x, because we're bringing it over the equal sign, minus 28 equals 0. So we need to find two numbers that multiply to this guy and add to the middle. So that would be x minus 14 and x plus 2. So those would multiply to negative 24 and add to negative 12. So then we solve for it. We make this one equal to 0 and this one equal to 0. And that means that x equals positive 14, and from the other factor, x equals negative 2, because you're bringing it over to the other side. So how we check is we go back to the original question, which is this one right here. And what we do is we plug in the answer into the left side and the right side to see if left side equals right side. So left side, you're going to have 14 over 4. So wherever you see an x, put in a 14. And then 7 over 14. Is it equal to 3? That's what we're trying to figure out. So that would be equal to the right side. So we continue on the left side. So in your calculator, you are putting 14 divided by 4. And you are subtracting 7 divided by 14, and you'll get 3. So as you can see, left side equals right side. That means that 14 is the answer. And then you're going to repeat the same step with the left side being negative 2 over 4 minus 7 over negative 2. Again, our question is it equal to 3? So in your calculators, you're putting negative 2 divided by 4, subtract 7 divided by negative 2, and you'll see that it is also equal to 3, so these are both solutions. Now we also want to check the non-permissible value. So in our denominator, since we don't have a division, it's just the denominators that we're looking for. The only variable we have is this one right here, where x is not allowed to be 0, because if that is 0, then the whole equation doesn't exist. So that's your non-permissible value. Our next example we're going to have to factor this first. We're going to have to factor it as y minus, let's see, y minus 6 and y minus 3. So those would multiply to 18, and they would add up to negative 9. And so then you want to get common denominator, so that means that this is going to have to multiply by y minus 3, top and bottom. And this first fraction is going to multiply by y minus 6, top and bottom. So then you're going to distribute that 9 into the bracket. So you're only going to do that to the top. So you're going to have 9y minus 54. And then you're going to have to distribute the negative 4 into the brackets. Negative 4y, you're going to have to distribute the negative 4 as well to the negative 3, which means positive 12. And that's equal to 18. Because we didn't have to do anything to the right side of the equation because it had both factors. Now this is over y minus 6 and y minus 3. And the right side is over y minus 6, y minus 3. And then what we're doing here is we're multiplying the left side by our lowest common denominator of y minus 6, y minus 3. And that's going to cross off with the bottom factors. And you're going to do the same thing on the right side, y minus 6, y minus 3. And it's going to cross off with all of that. So what you need to remember is that once you get common denominators, they are going to cross off. So that's the goal. So you're going to be left with 9y minus 4y. We can put that together as 5y. And then we have negative 54 plus 12. So negative 54, you're going to add 12 to that. And you should get negative 42. And that's equal to 18. Now we're going to bring that negative 42 to the other side. So 5y equals positive 42 plus 18. And that gives us 5y equals 60. And you can divide both sides by 5, which means that y equals positive 12. Now with this answer, before we put a check mark beside it, we still need to check our answer. So we would go back to the original question. And we would plug it in. 9 over 12 minus 3 minus 4 over 12 minus 6. Is it equal to 18 over 12 squared minus 9 times 12 plus 18. So we're substituting that 12 everywhere you see a y value. So you're going to have 9 over 9, which is 1, minus 4 over 6. Is it equal to 18 over? And in my calculator, I'm going to find what that is equal to. The bottom is 54. So 1 subtract 4 over 6 is equal to 1/3 because it's like 0.333 repeating. And 18 divided by 54 is also 1 over 3. So left side equals right side, which means that put a check mark. This is a correct answer. Okay. And then we also want to state the non-permissible value. So our non-permissible value here is y is not allowed to be positive 3. And from here, y is not allowed to be positive 6. So those are our two non-permissible values. So those are the only ones in all the denominators. So y can't be 3 or 6. And our answer should never be a non-permissible value. So always confirm that. Okay, so always make sure you find your non-permissible value from the original equation and not your answer, because your answer will actually leave some of them out sometimes once you simplify. So it's important to make sure that you look at the original question. Example number 3. So we have solve. What are the non-permissible values? So let's find the non-permissible values. We're going to have to factor this. This is going to be y minus 3 and x plus 2 and x minus 3. So those would multiply to -6 and add up to -1. The non-permissible values would be x cannot equal. From here you get -2 because you're just bringing that +2 over. And from here you'd get +3. So those would be the same as these two. So those are your non-permissible values. Our next step is to get common denominators. So we're going to multiply this first fraction by the x minus 3 because it's missing that top and bottom. And the second fraction is x plus 2 top and bottom. The right side of the equation has both of them, so you're done. You don't have to do anything to the right side of the equation. But for the left side, you need to distribute that 3x into x minus 3. So that'll be 3x squared minus 9x. And then you're going to have to distribute this -5 into the brackets as well. -5x minus 10. So that's going to be equal to -25, and then we write it as one common denominator, x minus 3, x plus 2. Same thing on the right side, I'm going to leave it as x minus 3, x plus 2. So that's the factored form. And now we always want to multiply the left side and the right side by that lowest common denominator. So you're multiplying the top by x minus 3, x plus 2. What I do to one side, do to the other. And what that does is it crosses off all the bottom pieces because they're identical. Whenever you have the exact same factors on the left side and the right side, they actually cancel each other out. So what you're left with is 3x squared minus 14x, because you're combining -9x and minus 5x, minus 10 equals -25. You're going to bring the 25 over to become positive. So that's equal to 0. And now we have 3x squared minus 14x, and that'll be plus 15 equals 0. So in this case, they're not going to be nice numbers. So what I'm going to do is I'm going to switch to either graphically solving for it or using the quadratic equation. So that's where you go x equals minus b, so that's -14, plus minus square root of b squared minus 4ac. Okay, so that's quadratic formula divided by 2 times your a value, which is 2 times 6, or 2 times 3, which is 6. Two negatives becomes a positive, so that's positive 14. And then we're going to put that into our calculator. So in brackets, you're going to put -14 squared minus 4 times 3 times 15. And you should get 16 underneath over 6. So that's going to be 14 plus minus 4, because the square root of 16 is 4. Divide that by 6. So we're going to have two answers that come from this. 14 plus 4 is equal to 18 divided by 6, which is 3. So they're saying that x could equal 3. And 14 minus 4 is 10. 10 over 6 is equal to 10 over 6 simplifies to 5 over 3. Okay, so let's state the non-permissible values. Well, we actually did already. We said x cannot equal -2 and 3, which means that this is not an answer. We need to cross it off because this is a non-permissible value. An answer is not allowed to be a non-permissible value. Next thing we would do is we would check the 5 over 3 to see if it's an answer. So you would substitute it into the left side, the right side. And if they're equal, then you know that you are you have your solution, right? So I know that this is going to be a solution, like if I plug it in. So you could put it as decimal into the calculator as long as you keep as many decimal places as possible. So I've already checked and it does work. So 5/3 is the solution to this problem, with the non-permissible values being -2 and 3. Example number 4 and 5 are word problems. Okay, so that's kind of like the hard part of this unit, I find, is being able to write an equation from the words. So I'm going to show you a way of setting this up. So these are the two kind of most common questions that you would see in 20-1 when it comes to word problems. So example number 4, you're going to start by creating a chart, which is going to look like this. You're going to have Stella versus Jose. So that's going to be what your chart is broken up to horizontally. And then our columns are going to look like this. We're going to have time. So how long does it take them to do the item by themselves? So the time by themselves. And then your second column is going to be 1/time, meaning how much could they do in 1 hour? So what fraction of the job have they done in 1 hour? And then the last column for this kind of situation is going to be time together over their individual time. Okay, so time by themselves. Stella takes 4 hours to paint the bedroom, so you're going to put 4, and that's in hours. Jose takes 3 hours to paint the same area on his own, so 3 goes there. We know that this would be 1/4, so it's going to take, they can finish 1/4 of the job if you give them 1 hour. That's what that's saying. And Jose can finish 1/3 of the painting job, meaning 1/3 of the room, in 1 hour. And then the time together. So time together is, we don't know that. So that's actually our question. How long will it take for them to work together? So whatever your question is, that should be your X. So this is our time together. So whatever we don't know should be set as a variable. So I'm going to put X and X at the top, and their individual time, well, Stella's individual time is 4 and Jose's individual time is 3. What you're always going to do in this set of problems when they're working together, working apart, you're always going to add them, and that's equal to 1. Okay, so that is your strategy for making an equation. So with this, working together, working apart, you're going to add their times, time together over time, and that should always equal 1. So we're going to solve this algebraically, and that's what we've been doing. So I'm kind of focusing on the algebraic approach here. So that's where you get a common denominator. So you're going to multiply the first fraction by 3, the second fraction by 4, and the right side you're going to have to multiply by 3 times 4, so both 3 and 4, which is 12. What you do to the bottom, do to the top. Remember, 12/12 is 1. It's not changing what the meaning of the question is. So what you should have is 3x over 3x plus 4x over the common denominator is 3 times 4, which is 12. And then that's equal to 12/12. And now what we do is we multiply this side by 12, this side by 12, and what those are doing is crossing off the denominators. So what you're left with is 3x plus 4x is 7x, and that's equal to 12. And then you're going to divide by 7 on both sides. X equals, you can put that into your calculator if you want, 12 divided by 7, and that's equal to 1.7, approximately 1.7 hours. So that's how long it takes them to do the job together. Okay, so that is one type of word problem. You're going to see that that kind of problem repeat itself in the next lesson. Example number 5 is a train has been scheduled to run 160 kilometers between 2 cities in Saskatchewan. If the average speed is decreased by 60 kilometers per hour, the run will take half an hour longer. What is the average speed of the train? So this is a distance, speed, time problem. So this is, we'll say this is one trip and this is the other trip. So we're just kind of dividing it as one trip versus another trip. Well, we know the distance going between the 2 cities in Saskatchewan would be 160. So the distance doesn't change for both the first trip you make and the second trip you make. What's our question? Well, our question is saying what's the average speed of the train? So that's going to be our variable x. X will represent the average speed of the train. So whatever your question is, whatever you're trying to find should be your variable. So that means if I go between the 2 cities, our average speed is going to be x. And then our second time we go, maybe we are decreasing our speed by 16 kilometers per hour. So you're going to go x minus 16. Time, guys, is always equal to distance over speed. So you're going to take 160, which is our distance for the first trip, and we're going to divide it by our speed, which is unknown, so we call it x. Our second trip is where we slow down our speed, and we're going 160 for distance and speed, x minus 16. Now, it says the run, where you decrease your speed, will take half an hour longer. So this one's going to be longer. So that should be first. The one that is longer or going to take more time should always come first. So we're going to have x over x minus 16 first. Then we're going to subtract, because they're saying the difference between their times is half an hour. And then you're going to put 160 over x here. And that's going to be equal to, we can say 0.5. So I'm actually going to do that because it makes it easier for working with the denominator. There's less denominators. So I'm just going to put half an hour as 0.5 instead. Okay, so with the algebraic approach, we want to multiply this by x, that's the first fraction, this one by x minus 16, because that's a different factor. And then the right side is going to multiply it by x and x minus 16, because it has nothing, and x minus 16, top and bottom. And then don't forget that we're going to multiply the whole left side by x and x minus 16, and the whole right side, this guy right here, by x and x minus 16. Those guys will cross off all the denominators, so they're all going to go away. So now I have 160x minus, we're going to distribute this minus 160 into the brackets to get minus 160x, and then in your calculator you're multiplying by negative 160 times negative 16 gives me positive 2,560. And that's equal to, we're going to have to distribute 0.5x into x minus 16. So that's going to be 0.5x squared, because 0.5x times x, and then 0.5 positive 0.5 times negative 16, which will give me negative 8x. So that's what I have on the right side. Now, what we'll notice is that these guys will cross each other off because they're the same numbers but the opposite sign. And then we just have to bring that 2,560 to the other side. Okay, and then in this approach, I'm going to go to the graphing calculator just to show you that there's different strategies that you can use. So this is the strategy we used so far. We factored already to find the answer. We've also done the quadratic equation so far. So what I'm going to do is put this into my graphing calculator, into y1 or y2, it doesn't really matter. Okay, so I'm going to change my answers to be realistic. So remember, this situation is talking about a train, the average speed of a train. Well, x is going to represent speed of a train, so I'm going to go from 0 to, let's go up to 200 kilometers an hour. Now, if we have to make it bigger, because we don't see the x-intercepts, you can always. And then our y is okay because as long as we see the x-intercept, meaning the x-axis, that's all that matters. So this would be a window where we could possibly see this. Okay, so there's one. Now I do want to maybe go to the other side just to see if there's another x-intercept. So yeah, so we can ignore this one right here. If you guys look, I'm going to go trace, and then I'm going to see if I can touch this. Let's see. So here, guys, in this case, so it's not really working here. It's not really functioning, but that left x-intercepts I can ignore. The reason being is that it's negative. We cannot have, in this case, a negative speed of a train, so I can ignore that one right there and then look at the value for the next x-intercept. Okay, so unfortunately it's not working for me. I'm trying to adjust it, but it seems to be having technical difficulties. Let's see if I can retry this. Okay, so unfortunately it's not working, guys. So I'm just going to kind of sketch what I want you to do. So remember, this is what kind of the picture looks like. You want to find this x-intercept because this one's negative. The left one's negative. So this is the one you're going to find. You're going to go second, trace, number 2. You're going to go for the left side up there, and for the right side, you're going to go there, right bound. And then that's going to give you an answer of 80 kilometers. So x equals 80 kilometers per hour, and that is the answer that you should be looking for. Okay, so just graph it, find the x-intercept, and then we're using the logical positive answer, not the negative one. Our exit task, they're just asking us for the non-permissible value. So t is not allowed to be -1 from this, and t is not allowed to be +3 from this guy. So that's our first step. Now they want us to solve algebraically, so that means you would multiply this first fraction by t minus 3, because that's what's missing. What you do to one side, what you do to one level, do to the bottom level. And then here, t plus 1, top, t plus 1. And then we're going to have to multiply the 3 by t plus 1 and t minus 3. What you do to the top, do to the bottom. And then what we're doing is we're multiplying the whole left side by that common denominator, t minus 3 and t plus 1. And we're doing the same thing on the right side. we're multiplying by t plus 1 and t minus 3, and that crosses all the denominators off everywhere. So what we're going to need to do now to solve algebraically is we're going to have to do a bunch of FOILs. We're going to have to do t minus 3 times 5t minus 2, so that'll give us 5t squared minus 2t minus 15t, and then plus 6. So that's FOIL from the first fraction. Now we're going to have to do FOIL for the next set of fractions. We're going to have to first distribute that sign as well. So that's something we need to watch for, is this negative applies to it all. So we're going to have to do negative 2t, so that's negative 2t plus 1 distributed to t plus 1. And that's equal to, on the right side, we should have 3 multiplied by our FOIL, which would be t squared minus 3t plus t, and then minus 3. So that's from FOIL. Here we're going to have to do FOIL as well. I'm going to start joining together like terms. So negative 2 and negative 15t will give us negative 17t. And then we're going to have minus 2t squared minus 2t plus t, and then plus 1 equals 3t squared. These guys are going to become negative 2t, and negative 2 times 3 is negative 6t, and then minus 3. Oh, sorry, should have distributed that 3 to it, so it should be minus 9 actually. Okay, so let's start simplifying stuff. 5t squared minus 2t squared will give us 3t squared. And then we have negative 17 minus, so we're going to first, so we'll go minus 17 minus 2t, which will be minus 19, and plus t, which will be minus 18t. And then we have 6 plus 1, which is 7. So that's the left side. The right side stays as it is. Now what you'll notice is you have the exact same terms on the left side and the right side, so they'll actually cross each other off. And then our next step would be to bring this one to the other side by adding 6t. So we're trying to join the t's together. So that would be 12t, negative 12t plus 7 equals negative 9. Then we're going to subtract 7 on both sides. So that gives us negative 12t equals positive or negative 16. And then we're going to divide both sides by negative 12. So that simplifies to a positive number, and you're dividing both the top and bottom by 4, so that gives us 4 over 3 as your final answer for t. Always check your answer, so I do know that this is an answer, but you should always substitute to see if left side equals right side. Okay, so that is your lesson 6.4a, and that's about solving for your rational equations. So make sure you practice this algebraic approach, and then in the next lesson